Hello everyone, welcome back to Pro Learning with Rish. In this video, we are going to learn about JDK, JRE, JVM, and also JIT because they all work together. Let's get started. Now start from here. JDK. JDK means Java Development Kit. This is for developers you can download when you want to write Java code. Inside JDK includes JVac, debuggers, documentation tools, and most importantly, you get the JRE inside it. Here, JRE means Java Runtime Environment. Later on, we'll go through deeply. So, JDK equals JRE plus development tools. Next is JRE, Java Runtime Environment. This is for running Java programs, not writing them, just running. If you want to play a Java game on your computer, you have to install JRE, not JDK. First, inside JRE, you have two things. The JVM, we'll get to that later. Second, Java libraries, which is pre-built code that Java gives you, like system.out.println. So JRE equals JVM plus libraries. Notice something, JRE lives inside JDK because developers need to run their code too. Okay, so now you know what each one is. JDK is for developers with tools. JRE is for running programs with libraries. But here's the question everyone asks, which one do I actually need? And the answer is simple. It depends on what you are doing. If you're a developer writing code, you need the JDK because you need JVac to compile. You need debuggers, you need the tools. Yes, the JDK contains the JRE anyway. So you also get to run your code, but you can't develop with just JRE. If you're an end user running a program, you need JRE only. No compiler, no headers, no source code, just the runtime. Smaller download, less disk space, fewer security concerns. Now let's move to the next part, which is JVM Java Virtual Machine. This is the heart of the entire Java platform. JVM is inside JRE. It's the actual engine that runs your bytecode. JVM does three main jobs. First, class loader. It finds your .class files and loads them into memory. Second, bytecode verifier. It checks if your bytecode is safe, no hacking, no crashing. Third, execution engine. This is where code actually runs. Inside execution engine, you have two things: the interpreter and the JIT compiler. Interpreter starts first, reads bytecode line by line, slow but works immediately. JIT watches, finds hot methods, compiles them to native code. So JVM is the boss. It contains everything needed to execute. That's JVM. Interpreter starts, JIT optimizes, CPU runs the native code. But right now, you might be thinking, wait, how do all these pieces fit together? JDK, JRE, JVM, what contains what? That's exactly what we're doing next. Let me draw you the hierarchy diagram so you can see the nesting. First, we'll draw the big box. Name it as JDK. Inside the JDK is JRE. Here it's a JVM. Inside the JVM execution engine, it includes interpreter and JIT compiler. Now that you understand JDK, JRE, JVM, and where JIT lives, let me show you how Java compilation and execution actually works using 5 diagrams. Here you can see the high-level block diagram. So this is the flow of Java execution. The first step is Hello, Java. It is the source code which is every developer's knows. Human-readable format. And source code is converting into the bytecode help of this Java compiler. So now it is hello, class bytecode. That bytecode goes into the JVM. Inside the JVM, there's an execution engine. It has 2 parts. 1. Interpreter. 2. JIT compiler. The interpreter runs code right away, but it's slow. The JIT compiler watches for the hot methods, the ones running over and over. It turns those into fast native code. Both end up running on your CPU. That's the whole flow. Here's how the JIT decides to act. The JVM starts interpreting your code. As it runs, it counts every method call. Then it asks one question. Has this method been called more than the threshold? No. Keep interpreting. Nothing changes. Yes? JIT compiles that method into native code. Next time that method runs, native code, fast. Count. Check. Compile. That's the loop. Timeline diagram. Watch what happens over time. Left side, everything is interpreted. Slow, because the JVM translates bytecode every single call. Then you hit the threshold. That's the moment JIT decides to act. Just-in-time compiler. Now the right side. Now the code is JIT compiled. Fast. And here's the key. JIT compiles once. After that, the same native code runs again and again. First part slow. Second part fast. Threshold is where the magic happens. This diagram separates compile time from runtime. Compile time. Your .java file becomes .class bytecode, sitting on disk. Nothing's running yet. Runtime bytecode moves into the JVM inside the execution engine. Interpreter runs it slow. JIT compiles hot methods into fast native code. One thing to notice, bytecode never touches the CPU directly. Never. It's always translated by either the interpreter or the JIT. Last one, the sequence, step by step. You write hello.java. Java compiles it to bytecode, the .class file. JVM takes over, loads it, starts interpreting, slow path. But the JVM is counting calls, hit the threshold. JVM tells JIT, compile this method. JIT compiles it once. After that, all calls run native, directly on the CPU. That's the handoff. You JAVAC, JVM, interpreter, JIT, hardware. So that's JDK, JRE, JVM, and JIT, all explained with diagrams. Let me quickly recap what we covered. We started with JDK, the development kit with all the tools. Then JRE, what was just for running Java programs. Then JVM, the engine that actually executes bytecode. And inside JVM, the JIT compiler, the reason Java runs fast after warmup. Then we went through 5 diagrams showing exactly how Java compilation and execution works from source code all the way to CPU. If this video helped you, please like, share, and subscribe to Pro Learning with Rish. And if you have any questions, drop them in the comments below. I read every single one. Thank you for watching. I'll see you in the next video.